All right, so for lesson 2, we're going to be talking about factoring and quadratics. So factoring a polynomial means expressing it as a product of other polynomials. So you should always look for a GCF first. Remember that stands for greatest common factor. And a greatest common factor is the largest monomial that will divide evenly into each term of the polynomial. So we're looking for the biggest number, biggest amount of variables that we can take out of each term. So if we look at number 1 here, we're looking to see what number can we divide all of these numbers by. So 6, 12, and 3 can all be divided by 3. And then we want to look for variables. So all of them have a C and a D. So we're looking for the least amount that each one has. So the least amount would be this C to the first power. So that's going to be our GCF. And then for the D, same thing. We're just going to have D to the first power. We can never pull out more than we have. All right, so in factored form, we're going to have the GCF out front. And then we're going to divide each term by that GCF. So for the first term, 6 divided by 3 is 2. You have 3 C's up top and 1 on the bottom, so that leaves you with 2 C's. And then the D's are going to cancel out. All right, for the second term, negative 12 divided by 3 is 4. You have 2 C's on top, 1 on the bottom, so you have 1 C left. And then same thing with your D's. All right, and then for the last one, the 3's are going to cancel, the C's are going to cancel, and so are the D's. So a lot of people, their instinct is to just close off the parentheses and say we're done. But anything divided by itself, this whole thing right here, is going to equal 1. So we can't just have that term gone. So if we started out with 3 terms, we should still have 3 terms within these parentheses. All right, so we're going to go ahead and go to the next question and look for what's the biggest number we can divide each of these numbers by. So we could divide them all by 2, but there's actually a bigger number that we can divide them by. So we can divide each number by 4. And then we need to look at our variables again. So the smallest amount of x's that all have an x, the smallest one is just going to be 1x. Each one also has a y. The smallest amount is going to be y squared. And then each has a z, so the smallest amount is going to be a z. So we're going to write that out in front of our factored form. And then we're going to divide each of these by our GCF. And you will be taking your final exam or your SOL on the computer. So I highly suggest you write questions down so you can actually work through them. And we're going to get 4. X cubed divided by x gives us x squared, y squared, and then the z's are going to cancel out. So remember, we're just subtracting exponents here. So if you have an x on top and bottom, just subtract their exponents. So 8 divided by 4 is 2. X squared over 1 will just leave us with 1x. The y squareds are going to cancel, and then we'll have 2 z's left over. All right, and then for the last one, we have 12 divided by 4, which is 3. Our x's are going to cancel. We'll have 1 y left over, and we'll have 2 z's. Okay, so once we do that, now we need to refresh on how do we factor a trinomial. So this is where if a equals 1, we can use our shortcut. So remember, a is the number in front of the x squared. So I'm going to go ahead and write my negative 32 over here. We're trying to figure out what multiplies to negative 32 and adds to negative 4. So that's going to be, there's like always a couple options if you write out all your factors, but in this case it'll be -8 and +4. So make sure to check that. -8 plus 4 equals -4. Cool, that's what we wanted it to do. So our shortcut is that we can just write our two sets of parentheses. This is going to be x, and we're going to have x minus 8, x plus 4. And that's going to be our completely factored form. So now if we go over to this one, now a is not 1, a is 2. So what we have to do is take that number and multiply it to the last number. So -10 times 2 is -20. And we want to figure out what multiplies to -20 and adds to -1. So we're always doing what multiplies to the last number, adds to the middle number. So in this case, it would be -5 and +4. So let's check that and make sure it equals -1. So -5 plus 4 equals -1. Perfect. All right, so now we have to do factoring by grouping. So we have to keep that 2x squared the same, and we're going to replace the middle term with those two numbers we found. So we're going to have -5x plus 4x minus 10. And then we group the first two together and look for our GCF. So the only thing that they have in common is an x. Everything else stays the same. We just take an x away from each term. And then here, they both can be divided by 2. So we'd have +2 and x, 2x minus 5. All right, so your whole goal is to get both of these to be the same. If they're not the same, then you must have done something wrong. So that counts as one of your factors. And then your other factor is going to be the combination of your GCFs. So it would be x plus 2. And then that is completely factored. Okay, so let's do a couple more examples. So for this one, a is greater than 1, so we're going to go ahead and do 2 times -20, which would be -40. And we need to think about what will multiply to -40 and add to -3. So in this case, the problem will be 5 and -8. If we do 5 minus 8, that equals -3, which is what we want it to equal. And we have to do grouping since a is 1, or is not 1. So we're going to have 2x squared plus 5x minus 8x minus 20. So remember, we're just replacing that middle term with the two numbers we found over here. All right, and then we're going to find a GCF between the first two. In this case, it's just going to be x. So we're going to have 2x plus 5 left over. And then between these two, because that first term is negative, our GCF should be negative. And we can divide both of those numbers by 4. So it would be 2x plus 5 left over, which is what we wanted. So we want these two to match. So 2x plus 5 is our first factor. And then we have x minus 4 as our second factor. All right, so we should always be looking for a GCF first. So if we go to number 4, we can divide all of these numbers by the same thing. So we can divide them all by 3. So that's what we'd want to do first. Don't forget to keep your GCF. So a lot of people like to just go ahead and divide by 3 and say it's gone. But we need to keep that GCF out front, otherwise we're not going to get the correct answer. So if we do 3 divided by 3, we're just going to be left with x squared. 39 divided by 3 is -13x. And 108 divided by 3 is 36. All right, so we're not completely factored yet. I'm going to go ahead and just write my GCF so I don't forget it. So what we're trying to do now, a is 1, inside of the parentheses. So ignore everything else and just look at what's inside the parentheses now. A is 1. We're going to figure out what multiplies to 36 and adds to negative 13. So if we want something to add to be negative and we're multiplying to a positive number, both of these are going to be negative. So we're going to end up with negative 13, which is what we wanted. And we can use the shortcut because a is 1. So we're going to have a minus 9, x minus 9, x minus 4. And that would be our factored form. So this GCF has to be in front. If it's not there, then you did not get it correct. Okay, so don't forget to include your GCF in your final answer. All right, number 5. So a is not 1 here, and we don't have a GCF. So we're going to go ahead and multiply 6 and negative 5, which would be negative 30. So we want to figure out what multiplies to negative 30 and adds to positive 13. So in this case, it would be positive 15 and negative 2. 15 minus 2 equals 13. All right, and then we're going to factor by grouping. So we're going to do 6x squared plus 15x minus 2x minus 5. All right, between the first two, we can divide both of those numbers by 3, and we can also divide them both by an x. So we're going to have 2x plus 5 left inside the parentheses. And then we can divide both of these just by a negative 1. And so we're going to have 2x plus 5 left inside. All right, so these match, which means we did it correct. So we're going to do 2x plus 5 as one of our factors and 3x minus 1 as the other. All right, and that would be completely factored. All right, this next one is for you to try on your own, so make sure you try this problem, get it correct. I'll give you a hint, it's a special case. It's going to be a perfect square trinomial. So do this one on your own and make sure it's filled out so you can get full credit. And if you have any questions, I'm happy to help you in class. All right, so for number 6 and 7, what we're trying to do is find a b value so that we can factor this trinomial. So there's going to be multiple answers. So let's think about it as we need something to multiply to 10, and we need it to add to that b value. So let's just list out the factors of 10. So we can do 1 times 10. We can do 2 times 5. And there's nothing else that we can, no other factors of 10. So the value of b would have to be what these equal when added together. So plus, plus. So it would be 11 and 7. We can also think about it as if both of them were negative. So if we made them both negative, so negative 1 and negative 10, negative 2 and negative 5, then negative 7, negative 11 and negative 7 would also work. So these are your 4 options that would work for b. So if we look at number 7, now a is not 1, so we need to do 5 times negative 4, which would be negative 20. All right, so let's think of the factors of 20. So we can start out with 1 and 20. And because the 20 is negative, that means that 1 is going to be positive and the other will be negative. So we could also think about this as 1 and negative 20. And then we can divide 20 by 2. So 2 and 10. 2 and negative 10. And then there's also 4 and 5, 4 and 5. So all we're doing is looking up all the possible combinations of multiplying to get negative 20. So now we need to figure out what are all of these things added together. So negative 1 plus 20 is going to be negative 19. So that's one of our options for B. 1 minus 20, I did that wrong. That would be positive 19. So negative 1 plus 20 is positive 19. 1 minus 20 would give us negative 19. Negative 2 plus 10 would give us 8. 2 minus 10 would give us negative 8. 4 minus 5 would give us negative 1. And 4 plus 5 would give us positive 1. So we have 6 possible answers to this question. All right, so on to the next page, or on to the back. So now we're going to do difference of squares. So difference of squares is where we take the square root of each of our terms. So square root of A, square root of B. Square root of A is A, square root of B is B, and that's what we write in our parentheses. And then difference of squares is always plus, minus. All right, and then x squared minus 16. So I'm going to go ahead and take the square root of each of these. Square root of x is x. Sorry, square root of x squared is x. Square root of 16 is 4. And then I'm going to do plus and minus. All right, 9. So take the square root. Square root of 4x squared is 2x. Square root of negative 80, or sorry, square root of 81 is 9. So we're going to do plus, minus. And it doesn't matter the order, you could do minus plus as long as you have both. All right, I'm going to do number 10 and I'm going to leave number 11 for you to do. So make sure you do that so that you can get full credit. So number 10, we're going to take the square root of both of these. And the square root of x to the 4th is x squared. The square root of 81 is 9. And we're going to do plus, minus. All right, so when your degree is higher than 2, you need to check to see if you can factor either of these further. So x squared plus 9 can't be factored anymore, but x squared minus 9 is another difference of squares. So we can factor that as x and then square root of 9 is 3, and 3. So we would have plus, minus. And that would be our completely factored form. All right, so for number 11, you won't be able to factor it any further after the first time you factor, like we could here. So go ahead and figure out what the square root of each of these is and write it in factored form. Okay. All right, then we have sum and difference of cubes. So the sum and difference of cubes, we use SOAP and SMS. So remember, SOAP is same, opposite, always positive. So that's what we're doing when we're talking about the sign. So same, opposite, always positive. So if we have the sign here is plus, same would be plus, opposite would be minus, and always positive is just always positive. And then we take the cube root of both of these, which gives us A and B. And then this is where the square multiplies square comes in. So that SMS. So SMS. So we square the first one. So we square A. We multiply A and B together. So it would be AB. And then we square the B. So B squared. Okay, so that's where we get our formula. That's where the SOAP SMS come in. So the same thing would happen here. So we'd have A, same sign, which is a negative, B. We'd have A squared plus AB plus All right, so let's do some examples. So if we have x cubed plus 64, make sure you take the cube root of each of these, and that's how we get our first set of factors. So that's how we fill out our binomial. So we would have x plus 8. And then we're going to put it in parentheses, and this is where the SMS and the SOAP come in. So I'm going to square my first term, so that would be x. So I'm going to make it x squared. I'm going to multiply the two together, so that would be 8x, and then I'm going to square the last term, so square that 8, so that would be 64. And then we need to do the same opposite, always positive, so that's where the first plus comes in, opposite would be minus, and always positive. All right, and that would be completely factored. So let's go ahead and do one more together, and then you could do the number 13 on your own. I'll do number 14 with you. So for number 14, neither of these are perfect cubes. So first thing we would need to do is factor out a GCF. So I'm going to see what I can divide both of these numbers by. In this case, it would be 3. So if we divide them both by 3, then we'd have 8y cubed minus 27. And now if we look inside our parentheses, now we have perfect cubes. So I'm going to do 3. I'm going to set up my binomial and my trinomial. Don't forget to keep your GCF. It doesn't just go away once you divide. All right, and then we do the same steps we did for the first one. So I'm going to take the cube root of the first term, that would be 2y, and the cube root of the second term would be 3. All right, and then we can go ahead and square, multiply, square. So square the first term, be 4y squared, multiply the two together, so 6y, and then square the last term, so 9. And then we do our SOAP. So same would be minus, opposite would be positive, and then always positive. All right, so make sure you fill out number 13 on your own. Just take the cube root of both numbers and set it up. So remember, we're just starting here, doing your binomial and your trinomial. All right, so last thing we have is our quadratic formula. So if we cannot factor to solve, then we have to use the quadratic formula. The quadratic formula will be given to you on the SOL, so it's not something that you need to memorize. And it's also helpful to utilize Desmos in this case. So most importantly, our entire equation has to be set equal to 0 first. So if we look at number 15, everything is set equal to 0. So then we need to figure out what A, B, and C are. So A is always going to be the number that's in front of the x squared. So A equals 3 in this case. B is going to be the number that's in front of the x. So in this case, it would be B equals -2. And C is always the number that's by itself. So that would be 1. All right, so once we do that, we plug it into the quadratic formula. So we're going to have x equals -b. So I'm going to put b in those parentheses, which would be -2. Plus or minus the square root of b squared minus 4ac all over 2a. So all of these parentheses should be filled out. So b squared, -2. A is 3, and C is 1. Okay, so obviously you're probably not going to want to color code this just because that's a lot of steps, but I think it's helpful to see the colors just so you know exactly where each variable is going into. So what we want to do next is simplify where we can. So we have this -2 times, the negative out front. We have a double negative. So -1 times -2 would make this positive, plus or minus. All right, and then this square root is a whole big thing, so I'm just going to leave it for now, and we're going to go to Desmos. So we have 2 times 3 on the bottom, that would be 6. So for Desmos, if we go to Desmos and type in b squared minus 4ac, that's everything that's underneath our square root. And a little throwback, that's also our discriminant. So it tells us a lot of things about the equation. So what we want to do is we can just literally type in a equaled 3. I'm going to type in 3. B equaled -2, and C was 1. So once we type that in, it gives us our answer. So it gives us that our discriminant equals -8. So we can go ahead and go back and type in or write -8 underneath the square root. So then once we get there, then it just is simplifying. So we have the square root of -8. This is where we have to figure out what is our perfect square we can divide 8 by, and also think about our negative. So we have square root, square root, square root. We have -1. Remember to always break away that negative. We have 4 and 2. So I picked 4 because I can divide 8 by 4, and that leaves 2. Remember that you can also just do like the tree where you break it down, whatever works best for you. And then for our final answer, or not our final answer yet, we're going to have 2 plus or minus. The square root of 4 is going to give us 2. Square root of -1 is I, and square root of 2 over, and still over 6. So our final step for our final answer is figuring out, can we divide all of these numbers by the same thing? So we can divide them all by 2, so I'm going to go ahead and do that, and that gives us our final answer, which would be 1 plus or minus I square root 2 over 3. Okay, so remember that plus or minus. So now for the next one, this one's not set equal to 0, so we need to do that first. So I'm going to subtract x from both sides, and then add 24 to both sides. So that would give us 6x squared minus x plus 24 equals 0. Once we get that, we can figure out what a, b, and c are all equal to. So whatever's in front of the x squared is our a value. So a equals 6. Whatever's in front of the x is our b value. So it's just negative, but remember that there's that imaginary 1 there. So b equals -1. And then c is whatever the constant is, so 24. All right, so I'm going to go ahead and do the same thing I did on the last problem where I kind of color code everything. So we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we're just plugging everything in from what we found. So a goes here and here. And this is just looking at the formula and plugging it in where we know. C is 24 right there. And then B is -1. Okay? So then we're just going to go ahead and simplify what we can and then use Desmos for the rest. So again, we have this double negative here. That's going to give us a +1 plus or minus the square root. Let's leave that for now and come back to it. Over, and we have 2 times 6, which is 12. All right, and then we're going to type that into Desmos. I already have it typed out just to save a little time on y'all's part. So 6, -1 of 24 gives us -575 underneath the radical. All right, so we need to figure out what we can divide 575 by to get our, or to simplify our radical. So I'm going to break it up again into my three radicals. I know it's 3 because it's negative. And then if I divide 575 by 25, that gives me 23. And then from there we can simplify. So this ends up with 1 plus or minus, we have 5 because of the square root of 25, I square root 23 all over 12. Right, and that would be your final answer for that one. All right, and finally, we are always going to get two answers when the discriminant is not equal to 0. The answers are called conjugate pairs. So the easiest question to get right is this kind of question if you remember your conjugate pairs. So whenever you have something that includes an imaginary number, they always come in groups of 2. So the only thing that you change to get the second part of that pair is the number or the sign in front of the I square root 3. So we would leave that -5 the same. And because it gave us plus, we know it also has to have a minus. Okay? So if we look at the next one, again, it's only whatever's in front of the I. We want it to be plus or minus. So we would make it 2 plus 27I for the conjugate pair. So you know that those two go together. All right, go ahead and finish the ones we didn't do together.